Hello, welcome back to Trigonometric Functions dealing with reference angles. And we're going to talk about a few problems. If finding values of trigonometric functions of any angle, let's talk about if an angle theta is quadrantal, then draw the angle and pick a point on its terminal side and apply the definition of trigonometric functions, right? Now, if an angle theta lies in the quadrant, what you want to do is find the reference angle alpha of theta, then find the value of the trigonometric function at alpha, and then adjust the sign, positive or negative, of the value of the trigonometric function based on the quadrant in which the theta angle lies. Now, we talked about in the last video dealing with the position of each of the angles in the quadrants and what signs are determinant of those. But let's talk about a problem real quick. And given this, cosine theta is equal to negative 2/3, and at pi over 2 less than theta less than pi, find the exact value of each of the remaining trigonometric functions. Now, if alpha is a reference angle for theta, then cosine alpha is equal to 2/3, and we have the adjacent side over the hypotenuse. Now, the reference angle alpha can be found by drawing the triangle using the Pythagorean theorem. Now, like we did so over here. Now, but we need to find the opposite side of alpha using the Pythagorean theorem. So as you see here, we have a being 2 plus b squared, which we have to find, is equal to 3 squared, which is the hypotenuse in this case, or the radius coming from here to that point. So 4 plus b squared is equal to 9. You have negative 4, taking negative 4 to both sides, of course, bring down our b squared. And remember, we have to solve for what? We have to solve for b. And that comes to be square root of 5. So, moving on, we can now find the remaining trigonometric functions of the reference angles, right? So, when we do this, sine alpha, of course, being the opposite over the hypotenuse, the opposite over the hypotenuse, which is the square root of 5 over 3, right, is what we have that exact value to be. And also cosine alpha being the adjacent side over the hypotenuse. And that'll be 2 over 3. And of course, tan alpha, which is the opposite side over the adjacent side, which is the square root of 5 over 2. And then of course, these are our what? Cosecant alpha, secant alpha, and cotangent. These are our reciprocal identities. Now, taking the reciprocal of those, we had to do some simplifying or rationalizing the denominator. And here's what we get for this: 3 times the square root of 5 divided by 5. And for secant alpha, we get 3 over 2. And for cotangent, we get what? 2 times the square root of 5 over 5. Now, after we found alpha, our reference angles here, now we have to make the adjustments. Because remember, when we make the adjustments and the appropriate, and of course assign the appropriate signs to each of the values, this is what we're going to do for the second part of this problem. So now the sine theta, okay, is the square root of 5 over 3. Now, let's look at this graph real quick. Where's the angle lying in this case? You have first quadrant, second quadrant, third quadrant, and the fourth quadrant. Remember that? Now with this angle falling into the second quadrant, we have that sine theta is considered to be positive here. So if you look at this here, we say all sailors take chances. This is a way of understanding and remembering where the angles lie in each of the quadrant speaking of being what is positive or negative, depending upon where the angle lies, theta, in these quadrants. So this helps you remember the trigonometric functions that are positive and, of course, are also negative in each of these quadrants, right? So, of course, in the first quadrant, all the trigonometric functions are considered to be positive, and then, of course, all scalars, meaning sine, theta, and cosecant theta, which in this entails that all of sine angles and cosecant angles are positive, but all the rest of the trigonometric functions are negative, and so forth and so on with the third quadrant of tangent theta, cotangent theta, which are positive, and all the rest are negative. And then you have what? Quadrant 4, which are what? Cosine theta and secant theta, which are also positive, and all the rest are negative. Now, getting back to this is how we know how to adjust or make the appropriate signs for each of the values. Being that this is in the second quadrant, we have that sine theta in this case is the square root of 5/3. That is considered, that would be positive angle. Now, as we continue on, we have cosine theta it would be negative, because in the second quadrant, cosine angles are negative, so it would be negative 2/3. And for tangent theta, same thing. That is negative 5, square root of 5/2. And then, of course, cosecant is also a positive angle in the second quadrant as well. So it will be positive 3 times the square root of 5/5. And of course, you have secant theta, which is equal to negative 3/2, and then cotangent theta, which is equal to negative 2 times the square root of 5/5. Let's look at another problem. Follow me. Now, we have this problem as well. Well, if tangent theta is equal to negative 4 and sine theta is less than 0, find the exact value of each of the remaining trigonometric functions of theta. Now, our solution, we want to say that since tan theta is equal to negative 4, which is less than 0, and sine theta is less than 0, it follows that theta lies in the fourth quadrant, quadrant 4. If alpha is the reference angle for theta, then tangent alpha is equal to 4, which is equal to 4/1. That will be considered B over A. With A equal to 1 and B is equal to 4, we find that when we use the Pythagorean theorem, we find our what? We find our long side to be square root of 17. So now that we found all our sides of the triangle, we can apply trigonometric function and find the exact values of each. So we find sine alpha, cosine alpha, and tan alpha, and also cosecant alpha, secant alpha, and cotangent alpha. So with this now, though we have these values, we can make our appropriate adjustments and also find out what our theta angles are, and where they will where they would be positive or negative, depending upon, in this case, this is the fourth quadrant, we'll know what is positive and what is negative. Now, sine theta in this particular case, as you see, 4 times the square root of 17 over 17 with negative 4 times the square root of 17 over 17, that would be considered negative, because the only things that are considered positive in quadrant 4 would be cosine and secant. So all the rest of the other trigonometric functions will be what? Will be negative. So that means that the sine theta value will be negative. And of course, we go to cosine, as we mentioned, that will be positive, square root of 17 over 17. And then you have tan theta, which is equal to what? Negative 4. We have cosecant theta, which is equal to negative square root of 17 over 4. And then we have secant theta, which is positive, is equal to square root of 17, and also cotangent negative 1/4. Take very, very good notes. Take your time, pause the video, rewind, and get any information that you need. And we're going to go on to the next lesson soon, so please stay tuned, and we'll see you really soon.